This is special right triangles. So we have two special right triangles, and it is their angle measures that will differentiate them. So we're going to look at the special side length rules for special right triangles. So there are two special right triangles. We have the 45, 45, 90, which happens to be the isosceles right triangle. So you will either see the 45-degree angles or you will see the isosceles congruent leg markings. The rule for this particular set is that the legs, because it is isosceles, are congruent to each other, and the hypotenuse is equal to our leg length times the square root of 2. You can also work backwards from this. If you divide by the square root of 2 and rationalize the denominator, you find that each leg is half of the hypotenuse times the square root of 2. So each leg is half of the hypotenuse times the square root of 2, and the hypotenuse is the length of a leg times the square root of 2. You get a 45, 45, 90 every time you draw a square with a diagonal. So the diagonal of the square separates it into two isosceles right triangles. Our other one is the 30, 60, 90. So within the triangle, you're either going to see a 60-degree angle or a 30-degree angle. Keep in mind that equilateral triangles have all 60-degree angles, and when you draw in the altitude, you split it in half. So an equilateral triangle with an altitude will give you two 30, 60, 90 triangles. So with this one, we have a short leg, a long leg, and the hypotenuse. So the hypotenuse is always going to be twice the short leg, and the long leg is going to be the short leg times the square root of 3. We can then work backwards from each of these two situations to figure out the short leg. So if you know the hypotenuse, you remove this by taking half. If you know the long leg, you would divide by the square root of 3 and rationalize the denominator. So we get that the long leg times the square root of 3 divided by 3. So if you will remember these two sets of rules, you can very quickly find a missing side length of these special triangles. Also, it only requires that I tell you one side length for you to find all three. So the first task for you to do is to actually look very closely at the triangles and see whether you have the 45 45s or whether you have the 30 60 90s. Keep in mind that 45 45s happen to be the isosceles right triangle. So once we figure out which of our triangles it is, we're going to label which sides we have, and then we're going to calculate for the ones that are missing. So in problem 1, there is a 60-degree angle. So we're going to use the 30, 60, 90 rule. So in a 30, 60, 90, I have the short leg, I have the long leg, and then I have the hypotenuse. One of these is always given. In this particular problem, we're given the short leg. So we go up here to our rule, and according to the rule, the long leg, which is x, is going to equal the short leg of 8 times the square root of 3. And we're going to leave this in radical form, so that's the answer. Our hypotenuse, which is y, is going to equal twice the value of the short leg, So we're going to do 2 times 8 to get 16. Problem 2, there are no angle measures, but we are shown that we have 2 congruent sides. So this is going to be the 45, 45, 90 triangle rule. So in this particular set, we should have 2 legs that are congruent. So our x is going to equal our y, and we should have a hypotenuse. And according to our rule, our leg equals our leg, and they are both equal to our hypotenuse value divided by 2 times the square root of 2. So 10 divided by 2 is 5, square root of 2. In the next one, there is a 45-degree angle. So this one is going to use our 45, 45, 90 rule. So we should have 2 legs, and they're equal. So our leg of x is equal to our leg of 7. And then we have our hypotenuse, which is y, and our hypotenuse is equal to our value of the leg times the square root of 2. And since we're asked to leave this in radical form, that's our answer. So in our next set, once again, we begin by looking very closely at the picture. There is a 30-degree angle in this right triangle. So this is our 30, 60, 90 right triangle. So the longest side is the hypotenuse, and then we will have a short leg and a long leg. One of those will be a number value, and we're going to use that to find the other 2. So we're looking for the short leg, and we're looking for the hypotenuse. The hypotenuse requires the short leg, so we actually have to find the short leg first. So we're looking for the short leg, and it is equal to, we have the long leg times the square root of 3 over 3. The hypotenuse, which is our y, is equal to our short leg times 2. So we're going to do 2 times that value of the short leg, the 8 square root of 3 over 3. So we're going to do 2 times the 8. We're going to keep the square root of 3, and we're going to keep the over 3. Problem 5 is a rectangle, and if we look within that rectangle, there is a 30-degree, so we're only taking half of our rectangle. So half of this rectangle creates a 30, 60, 90 right triangle. The diagonal will be the hypotenuse. The short side of our rectangle is the short leg, and then the long side of our rectangle is the long leg. So this particular question is the same process as the previous one. So the only difference is we're using a 10 instead of an 8. Same process, new number. So our short leg will be calculated by taking the square root of 3 and dividing by 3 with the long leg. 10 over 3 doesn't simplify, so this is our value of the short leg. The hypotenuse will be calculated by taking 2 times the value of the short leg. So we're going to do that 10 square root of 3 over 3. We do the 2 times the 10 and keep everything else. And that is the value of our hypotenuse. Problem 6 is a square with a diagonal. So you'll notice that we have 2 congruent sides. So that's our isosceles. So remember 45/45s are the isosceles right triangles. So with this set, we should have a hypotenuse and 2 legs. According to this rule, the first leg will equal the second leg, and our hypotenuse is equal to the leg measurement times the square root of 2. And since we're asked to leave these in simplest radical form, that's our answer. Problem 7 is once again a rectangle. So if we look very closely, there is a 60-degree angle. So we're going to take half of this rectangle. This is going to be our 30, 60, 90 triangle rule. So you should be able to identify a hypotenuse. The short side of your rectangle is your short leg. Notice that's the one that we know this time. And the longer side of your rectangle is the long leg. So when we look at our rule, we know the short leg. So we're going to find the hypotenuse and we're going to find the long leg. So the longer leg is x, and it will equal the length of our short leg times the square root of 3. That is simplest radical form. The hypotenuse is y, and it will equal 2 times the short leg of 20, and 2 times 20 is 40. Our next picture has these congruent sides. So this is our isosceles right triangle in half of a square. So we're going to use the 45, 45, 90 rule. Identify the hypotenuse. The hypotenuse is your longest side. And then we have our 2 congruent sides are the legs. According to our rule, our values of the legs are equal to each other, and they are equal to half of the hypotenuse times the square root of 2. So we're going to take half of 18 and then multiply by the square root of 2. Half of 18 is 9, and we multiply by the square root of 2. Problem 9, you see that we have a 30-degree angle and a 90-degree angle. So if we take just the half of the picture with the 30 and the 90, we're working with a 30, 60, 90. So we are working with our 30, 60, 90 triangle rule. Pay attention to the marking. So this single slash mark is the X. In a 30, 60, 90, you have the hypotenuse. You have a short leg. And then you're going to have the long leg. In this particular one, we know the longer leg. So we're going to have to calculate the short leg when we know the longer leg, And then we're going to have to calculate the hypotenuse using the short leg. So let's start with the short leg. Our short leg is x, and we are going to calculate it by doing a divide by 3 and a times the square root of 3 using the longer leg. This particular value does simplify. 3 will go into 15 5 times, and we keep the square root of 3. Our hypotenuse, which is the y, will be calculated by doing 2 times the short leg. So we're going to do 2 times the 5 square root of 3, and we end up getting 10 square root of 3. So pay close attention to your rules. The better you know these rules, the faster the questions will go. In the next ones, they're going to describe a shape that we're going to sketch. We're going to fill in the information. We're going to find the value. And notice that this time we are rounding decimals to the nearest tenth. So instead of leaving them in radical form, we will be rounding our decimals. So in the first one, our sketch is going to be a square with a diagonal. I'm going to have a square with a diagonal. The perimeter of the square is 20, so you have to be careful. Perimeter is 4 times the length of a side. 20 is 4 times the length of a side. So 5 is the length of a side. So each of our sides is 5. This makes 2 isosceles right triangles. We are looking for the hypotenuse. So our diagonal is the hypotenuse, and this is equal to the leg value. So this is our leg value of 5 times the square root of 2. So that's what we need to calculate, 5 square root of 2, and round it to the nearest tenth. We get 7.1 centimeters. In the next one, we're going to work with the altitude of an equilateral triangle. So an equilateral triangle with an altitude gives us a 60-degree angle down here. So we end up with half of this is a 30, 60, 90 right triangle. The altitude is 18. In a 30, 60, 90 triangle, it turns out that the altitude is the long leg. Our altitude splits one side in half, so that's our short leg, and then the whole side of our triangle is the hypotenuse. So when it asks us to find the side measurement, our side of the equilateral triangle is the hypotenuse of our 30, 60, 90. And according to our rules, this is going to equal 2 times the short leg. We actually don't have the short leg, so we need to remember that the short leg is going to be calculated doing a divide by 3 times the square root of 3 with the long leg, which is our 18. So it turns out 3 goes into 18 6 times. So we have 6 square root of 3. So when we do our multiplication, we're going to do 2 times our 6 square root of 3. And when we round it to the nearest tenth, we're going to get 31.2 inches. For the next sketch, we have been asked to draw an isosceles right triangle. This is our isosceles right triangle. Whenever it is isosceles, we're dealing with the 45-45-90 rule. We are given that the hypotenuse is 16, so our hypotenuse is 16, and we are asked for the length of a side. So our side that we're looking for is the leg value, and the leg value is calculated by taking the hypotenuse value, dividing it in half, and multiplying by the square root of 2. So our leg length, when we calculate, 16 divided by 2 is 8, and 8 times the square root of 2 gives us approximately 11.3, and since this is in centimeters. In the next one, we're dealing with the diagonal of a square. So we have our square with the diagonal. So when we take half of the square, we have a 45-45-90. The diagonal of the square is equal to the hypotenuse, and our sides of the square are the legs. So our side of the square is equal to the legs, and our hypotenuse is 5 square root of 2 over 2. So this is going to look like a really challenging calculation because according to our rule, our leg is going to take half of the hypotenuse times the square root of 2, and our hypotenuse is 5 square root of 2 over 2. So when you look at this, the square root of 2 times the square root of 2 is 2, and 2 divided by 2 is 2. So all of that information there on the top ends up canceling out, and you're left with 5 over 2, which is 2.5 for our answer. The other thing that you can look at is you can remember that your hypotenuse is equal to the leg times the square root of 2. So when we have a 5 square root of 2 over 2 is equal to the leg times the square root of 2. If you take away the square root of 2 from each side, our leg is the 5 over 2. In this last question, we're actually going to use special right triangles. So notice that within the diagram that we have an angle of depression that is 60 degrees. So this angle going down the hill is 60 degrees. So we end up with a 30, 60, 90 triangle. And they tell us that this other half is congruent. So finding the distance across the canyon is we're going to find this measurement and then double it. So we end up with our hypotenuse is the canyon wall. Our distance across half the canyon is the short leg, and our vertical distance down the canyon is our long leg. So that's the one that we know. Keep in mind that your short leg can be calculated by doing a third of the long leg times the square root of 3. So for this one, we're going to take the 4,500, divide it by 3, and multiply by the square root of 3. 45,000 divided by 3 is 1,500, square root of 3. And then to get all the way across the canyon, we're going to do 2 times the short leg, which also happens to be the hypotenuse. So we're going to end up getting 3,000 times the square root of 3, which is approximately 3,000 times the square root of 3 is approximately 5,196.2 feet. Our length of the canyon wall is the hypotenuse. And notice that I mentioned before that our distance across the canyon was 2 short legs, which is the same thing as our hypotenuse. The hypotenuse is always equal to 2 times the short leg. So this is the same answer as the previous question. The length down the canyon wall is also 5,196.2 feet. If a mile is 5,280 feet, is the canyon more or less? Well, we're looking at a number that is less.